Today's lesson is on writing equations of parallel and perpendicular lines. So what's going to happen is you're going to be given an equation and a point, and you're going to be asked to draw or come up with the equation for another line that's either parallel or perpendicular to the first line that goes through the point you were given. So for example, equation passes through the point 1, 2, and is parallel to y equals negative 3x minus 4. So we're given this equation. We want to come up with a line that's parallel to this line, but it goes through the point 1, 2. And remember, those two lines just mean parallel, it's shorthand. So what I'm going to do is I want slope-intercept form. It's going to look like this, which means I'm going to need slope and an intercept. The best way to do this, though, is to use point-slope form, which is what we did the other day. Y minus y1 equals m times x minus x1. So start in this form and then simplify it into slope-intercept form, which means we're going to need to know what the slope of our line is. When we have two lines that are parallel, they have the same slope. So the slope of our line is going to be negative 3. So I can just put that right into my equation. We have y minus, and then I need to go through this point. So this will be my x1, this will be my y1. Times x minus 1. There is an equation for my line. This is in point-slope form, so let's just change this into slope-intercept form. So my first step is going to be to distribute y minus 2 equals negative 3 times x minus negative 3 times 1. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3, so y minus 2 equals negative 3x plus 3. Then I'm going to add 2 to each side to get the y by itself, so y equals negative 3x plus 5. And that's going to be my equation that is parallel to negative 3x minus 4 and also passes through the point 1, 2. And if I wanted to, I could graph that, and we could just see if that's true or not. Let me find some graph paper. So real quick, let's graph these and see if we accomplished our goal. So our first line is y equals negative 3x minus 4. Our second line is going to be y equals negative 3x plus 5. Let's do a quick graph. Draw my x and y axis. Okay, so for my first line, let's start at my y-intercept, which is negative 4. So 1, 2, 3, 4. My slope is negative 3. So I go down 3 over 1. I'm going to go up 3 and back 1 so I don't run off. And let's connect those dots. So there's line 1. And then let's draw the one of the equation that we came up with. I'm going to start at positive 5. 1, 2, 3, 4, 5. Because that's my y-intercept. And I'm going to go down 3 over 1. Down 3 over 1. Let's connect those points. And those lines look pretty darn parallel to me. I also want to check and see, does this go through this point 1, 2? Over 1, up 2? Oh, look at that. 1, 2 is on the line. So that's how we're going to do it with parallel lines. Remember, parallel lines have the same slope. They need to be changing, or they need to have the same rate of change over time, because they're never ever going to run into each other. You know, if they had different slopes, then they're going to end up running into each other. The other type of line that we might have is we may have a perpendicular line, where we want to make an equation for a line that's perpendicular. Remember, perpendicular lines intersect at a, they intersect at a 90-degree angle, and if you have the slope of one line, the slope of the perpendicular line is the opposite reciprocal. Perpendicular lines have opposite reciprocal slopes. So opposite means if one is positive, the other is negative, or if one is negative, the other is positive. Reciprocal means the flip. So remember, the reciprocal of 1/2 is 2 over 1. So the opposite reciprocal of 1/2 would be negative 2 over 1. If our slope is 4/3, the reciprocal of that is 3/4. Let's say we started with a slope of negative 4/3. Our new slope will be positive 3/4, or the slope of our perpendicular line will be 3/4. So, let's see. Let's write an equation of the line that passes through the point 1, -1, and it's perpendicular to a graph that goes through -2, 0, and 2, 2. So this is our original line. I want to draw a line that's perpendicular to this one. So the very first thing I have to do is I have to figure out what the slope of this line is. Once I find the slope of this line, I can do the opposite reciprocal to find the slope of my new line. So let's make this x1, y1, x2, y2. My slope formula, y2 minus y1 over x2 minus x1. So 2 minus 0 over 2 minus -2. 2 minus -2. That will be 2 over 2 plus 2, which is 4. So my slope will be 1/2. So this is the slope of my original line. That means the slope of my perpendicular line is going to be the opposite reciprocal, which actually I did up here. So the slope of this line needs to be -2 over 1, or just -2. So let's use this point slope form. And this is going to be my x1 and my y1. So put in -2 for m. Y minus -1 equals -2 times x minus 1. Subtracting a -1 is the same as adding 1. So -2 times x minus 1. Let's distribute. -2x minus -2 times 1 minus -2. -2x plus 2. So y plus 1 equals -2x plus 2. I need to subtract 1 from each side, and I will get y equals -2x plus 1. And that is going to be the equation of the line that's perpendicular to this line, but goes through that point. So the thing that we had to do here that was a little bit different, we weren't given the slope in an equation. We had to actually find out what the slope is. We don't even know the equation of this original line, but we were able to come up with the equation of a line that's perpendicular to it. So that's the whole lesson for today. It's basically just getting a little bit more practice with writing equations for lines. So good luck.